Hey nerds, welcome to our first video. In this video, we'll be discussing blood bottles, their various additives, and the CLSI certified order of draw. But before we jump right in, here is a word of encouragement to you. I want you to always remember that you've got a bright future ahead, and the sacrifice you are making to learn this is certainly worth it. Kudos nerd. Let's jump right in. In this video, we'll be looking at blood bottles under the following headings. We'll have a brief introduction and take a look at a few important definitions. The types of blood bottles in order of draw, their additives and the specific investigations they are used for. We will also take a look at some well-crafted mnemonics to help your hot brains memorize each bottle and its unique additive in order of draw. Precautions to be taken while handling blood bottles. We'll have a little quiz to help solidify what we've learned, and then we conclude. Let's go. First of all, what are blood bottles? Blood bottles, also known as vacutainers, are sterile glass or plastic test tubes with a colored rubber stopper used for collecting, transporting, and preserving blood samples for laboratory testing. Each bottle contains specific additives or anticoagulants indicated by its cap color, which determines the type of test the sample is suitable for, which may be hematology, biochemistry, coagulation, or microbiology investigations. Additives are defined as chemical substances applied on the inside of blood bottles having one or more specific functions such as preventing clotting or preserving certain blood components. The order of draw is simply defined as the standardized sequence in which the tubes should be filled to avoid cross-contamination of additives, which may lead to erroneous laboratory results. Now, let's look at each blood bottle following the standardized sequence of draw. First, we have the blood culture bottles. They are the first in the order of draw as it is important to reduce the risk of contamination to the barest minimum. They contain an anticoagulant known as sodium polyanethyl sulfonate, which acts by preventing coagulation by binding to calcium. In addition to being an anticoagulant, it reduces the action of complement, slows down phagocytosis in the blood, and reduces the activity of certain antibiotics. As the name implies, it is used majorly for blood culture. As a side note, in a situation where blood culture samples has to be taken for aerobes and anaerobes, samples for aerobes should be taken first before anaerobes. These bottles require 8 inversions to prevent clotting and ensure proper mixing of blood with the anticoagulant. Next, we have the light blue capped bottle. It contains an anticoagulant known as sodium citrate, which prevents coagulation by chelating calcium. It is best used for coagulation tests such as prothrombin time, activated partial thromboplastin time, fibrinogen levels, as well as D-dimer levels, which is usually elevated in conditions such as pregnancy, deep vein thrombosis, and pulmonary embolism. It is also used for thromboelastography studies, known also as TEG studies. 3 to 4 gentle inversions are required for adequate mixing of blood with the anticoagulants. Next, we have the red capped bottle, also known as the plain bottle. It contains no additive, hence the name, plain. It is used for investigations requiring serum such as serum total complement activity and serum cryoglobulins. As a side note, this bottle may contain an additive known as silica clot activator, which helps speed up the blood clotting process in order to give the required serum. Ensure to invert the tube 5 to 6 times after blood collection. Next is the gold-topped bottle, known also as the serum separator tube. It contains silica a clot activator, as well as a serum separating gel that creates a barrier between serum and the blood cells. It is used for investigations such as serum electrolytes, urea and creatinine, bone profile, liver function tests, thyroid function tests, troponin, lipid profile, immunology, serology, etc. Ensure to invert the tube 5 to 6 times for proper mixing of blood with the additives. Next, we have the green capped bottle, which contains an anticoagulant known as lithium heparin, which prevents blood clotting by activating antithrombins, which inhibit thrombin and factor X. It is used for many assays such as serum electrolyte, urea and creatinine, ammonia levels, HLA typing, chromosome testing, lactate levels, ionized calcium, blood urea nitrogen, plasma hemoglobin, etc. It is important to invert the tube 8 to 10 times following blood collection. Next, in the standardized order of draw is the purple capped bottle. It contains an anticoagulant known as ethylene diamine tetraacetic acid, also called EDTA. It is used mostly for hematology investigations such as full blood count and differentials, also known as the complete blood count, white blood cell count, platelet count, mean corpuscular hemoglobin, erythrocyte sedimentation rate, Coombs test, and flow cytometry. It is also used to assess blood levels of tacrolimus, which is an immunosuppressive agent used in organ transplant, as well as blood levels of cyclosporine, a calcineurin inhibitor used in the treatment of Crohn's disease and rheumatoid arthritis. The tube should be inverted 8 to 10 times following blood collection to ensure proper mixing of blood with the anticoagulant. Now let's pause here for a minute while we take a look at a mnemonic that will help us memorize the first 6 tubes and their additives respectively. It goes: brave souls leap swiftly, reaching peak goals, surpassing great limits, pursuing excellence. Aside being a mnemonic, I want this to also serve as a reminder to you to continually pursue excellence, and you will achieve heights higher than you ever imagined. Let's continue. Up next, we have the pink capped bottle, which also contains EDTA as its additive. It is used for investigations such as group and save, cross-match, direct antiglobulin test, also known as the direct Coombs test, as well as HIV viral load. Ensure to invert the bottle 8 to 10 times to ensure proper mixing of blood with the anticoagulant. Next is the royal blue capped bottle, which also contains EDTA. It is used to test for trace elements such as zinc and copper, heavy metals such as mercury, lead and arsenic. It is also used to test for various drug levels and also important in toxicology. This bottle should be inverted 8 to 10 times after blood collection. Next, we have the tan colored bottle containing a special kind of EDTA known as sodium EDTA, which also acts by chelating calcium and is an anticoagulant. It is used majorly to investigate for lead levels in the blood. Ensure to invert the bottle 8 to 10 times after blood collection. Next, we have the grey capped bottle, which contains an additive known as fluoride oxalate. Fluoride oxalate is a compound composed of sodium fluoride, which is a glycolysis inhibitor, and potassium oxalate, which is an anticoagulant. Fluoride oxalate acts by binding to calcium to inhibit blood coagulation and also prevents glycolysis. It is also called an antiglycolytic agent. It is used to test for blood glucose levels, serum lactate levels, and it's also used for toxicology screen. Inversion 8 to 10 times is essential for proper mixing. Moving on, we have the yellow capped bottle, and the additive contained in this bottle is an anticoagulant known as acid citrate dextrose A. It prevents coagulation by binding to calcium. It is used for tissue typing, DNA studies, and HIV cultures. Inversion of the tube 8 to 10 times following blood collection is also important. Finally, we have the white capped blood bottle, which contains a separating gel and EDTA. It is used for polymerase chain reactions for adenovirus, toxoplasma, and human herpes virus 6. Now let's take a look at another set of mnemonics that will help us memorize the last 6 bottles we looked at. I hope this mnemonic motivates you and keeps you working earnestly for the bright future you have ahead of you. It goes: pursue excellence relentlessly every time, embrace growth, forge your aspiring way every day. I hope the mnemonics help you recall these blood bottles and their various additives better. Now, here are a couple of precautions to take while handling blood bottles to ensure optimal outcomes and reduce the risk of laboratory error. First of all, never shake or vigorously mix a specimen, as this can lead to hemolysis, making the specimen unsuitable for testing. Also, never transfer blood collected from one bottle to another, even if the additives are the same. Different additives may interfere with each other or the testing process, leading to erroneous laboratory results. And finally, if microclots are detected in a hematology specimen, it cannot be used for testing and should be taken again. Finally, let's have a short quiz to help us solidify what we've learned. Let's go. And with that, I want to say a very big thank you for watching this video. See you in the next video. Bye nerds.